And today's topic is going to be object-oriented programming in R. But before I did that, I wanted to spend a little bit of time just talking debugging tips and strategies. Some of you guys came to office hours, and I see some questions posted on the class Piazza. And so there's just a few things I wanted to say, all right? And so one strategy is print statements or cat statements everywhere in your code, okay? And because I think a lot of times the reason why people's code do not work is that a condition that they believe is true is not actually true, or vice versa. They believe a condition is false, but it's actually true. And so it is helpful to, during the execution of the code, to actually print out the values of the variables, okay? And if you are able to see the values of the variables as the code is running, then you can get an idea of why is the variable taking on this value, okay? Because if you don't, then you have no idea why your function is running the way it's running, okay? So anyway, I thought I would just write this terrible function, and don't do it this way, okay? But here I just have a function to see, is there a winner in row 1, okay? And what this will do is it's going to just start off, it's going to take in, accept as an argument, the state, and it's going to check, it's going to first assign no winner to the result, okay? But if state space 1, space 2, and space 3 are all equal to x, so it says state 1 is equal to x, and state 2 is equal to x, and state 3 is equal to x, then we're going to print x wins, and we're going to change the value of results to x, okay? And over here, I've got if state 1 is O, and 2 is O, and 3 is O, then I should print O wins. And the result, it's going to update to O, and it's going to return the result, okay? So this is what we'll do. And then over here, I have just kind of this function called f1. And we're going to start off by saying no winner is equal to true. We're going to say state is equal to repeat NA 9 times. And we'll say while there's no winner, first we will check to see if there's a winner in the state, okay? And we'll save the result as result. And if the result is X or the result is O, we're going to change no winner to false. And then that will cause the loop to stop running the next time, okay? So this is what we have. Okay, so let's try this. Do you guys see any issues with this? So we'll run winner is R1, winner in R1, and then I create a function. So I've got f function 1 and winner in row 1. Okay, so I'm going to call f1. And right off the bat, I get an error. It says error, and if state 1 is equal to x, state 2 is equal to x, state 3 is equal to x, and it says missing value where true false is needed. Now, you might see this and recognize the problem immediately, okay? But let's say you're not quite sure you are getting that error, okay? So what I often find to be helpful is that we will print. So you can just print the values of our variables, okay? So because it's going to run on no winner, so right now no winner is true, we can just see, what is the value of no winner, okay? And so you can do print no winner, and then we'll run f1 again, and it just prints out true and whatnot, okay? And so it's actually, we realize, if I just see this statement true, I might not know exactly what that is. So a lot of times I like to use cat, and I'll say cat no winner equals no winner, and we'll put in a new line character after that, okay? And so this way, by inserting this cat statement here, when I run F1, okay, then at least this is helpful. I can know that the value of the no-winner variable is equal to true. Okay, this doesn't answer my question right now, but at least I know what the value of this thing is. Okay, and here we're gonna run result is winner in R1 state. Okay, so what could be helpful here is we're gonna say cat state is equal to, and we'll print out the state as well, okay? And we'll put in a new line character. All right. Okay, and then, so now if I run F1, now we start to get an idea, okay? So no winner is true, the state is missing, 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 okay? And now we can start to see that, okay, state 1 is X and state 2, and all of this stuff. We can start to see, well, okay, maybe this starts to make sense, okay? Now, one thing that you can do is just so you can kind of turn on and off these print statements all at once, is you can use an option called debug, and we'll set debug equal, by default it'll be false, but then when you call it, you can say debug is true, okay? And so here I'm going to do if debug, okay, in front of the cat statements. Okay, so if debug is set to true, then it will print the cat, and if debug is set to true, it'll print this cat, but if it's false, it won't print these statements, okay? So if I do this, and I run F1, it doesn't print any of those cat statements, but if I run F1 with debug set to true, then it does print the cat statements, okay? And so just by putting this if debug on and off, you can decide whether or not these cat statements get printed, okay? Which is often helpful because a lot of times you might just put like a comment to comment out the cat symbol, and then later on you say, well, actually I want the cat symbols turned back on, and you got to go through and you got to find all of these things. So if you just take a moment and you say if debug, then when you call the function, you can turn these things on and off just in the calling of the function, right? Okay, so now we can see that the state is missing, missing, missing. What we can also do here is we'll set an option for debug, okay? And we'll do this as well. And we'll say if debug, okay, because this debug is either going to be true or false. We can say cat, and we'll just print out all of the variables. So we'll say result is equal to, and then we'll type in result along with a new line statement. Another thing you can do is you can write if debug, and this will also help you track down your errors. At the beginning of each function, you can just say cat, we are inside function winner in R1. Okay, so every time this function gets called, it'll print this statement out. Okay. And I don't know, you can put a little some stars here, okay? So we're putting these things. Result is currently no winner. And then what I like to do is I like to print out for every if statement that gets triggered, okay? We're going to, other than the debug ones, okay? We're going to cat what that condition is, okay? So we're going to say condition, and we write what this condition is supposed to check, right? Condition x wins row 1 is equal to, and then we'll put in that condition. Okay, does that make sense what I'm doing here? So, because sometimes you'll have these complex conditions, and you think it takes on a certain value, but it's actually not. Okay, and so this will give you an idea of what's going on here. Okay, so I'm going to go ahead and I'm going to kind of just source all of this, and we'll call. And now I'll execute debug with setting equal to debug. Okay, So we're going to call F1 with, debug equal to true. Did that not run? Sorry. Okay, so when it runs, okay, with debug set to true, we have no winner is true, state is missing, and then it says we're now inside function winner no result. Oh, okay, and I forgot the new line character, so result is no winner, okay? And then here it says condition, x wins row 1 is equal to, and then it tells me that it's missing, NA. So this gives me an idea that, oh, you know what? The reason why I'm getting this is because when I'm checking all of these things, this if statement, I'm getting a missing value, okay? So, and that makes sense, right? Because right now, the spots in state 1, 2, and 3 are all missing. So if we just pause for a moment, we can say, oh, you know what? If any of the spots in row 1 are missing, then we know there's no winner for row 1, right? Because you can only have a winner if it's all X's or all O's. So if any of the spots are missing, we know there's no winner, okay? So what we can do is we will create a new if statement, okay? And we're gonna just say if any of the spots are missing in state 1 through 3, okay? So if anything in state 1 through 3 is NA and any of them are, then we will just quit and we're going to just return the result. Okay, and so I'll save this now and we'll source this. Okay, and so when a function encounters a return statement, it's going to stop. It's going to stop the function and quit out. Okay, so now we'll try this. We'll try F1 with debug set to true, and we'll see what happens. Okay. Oh, and now it seems like it's our thing is running forever. Okay. Maybe this is not what we wanted. Okay, because what I wanted was it's going to check to see if it's a winner, and if there is a winner, if it becomes a winner, it's going to stop, right? But if there's no winner, then what we wanted was I wanted I equal to be 1, and we're going to put an X into state 1, and then I increment I to be 2, and then I would want to update state position 2 to be an X, and then I would increment and state position 3 to be an X, and then I would expect it to quit. But what we see is that that's not what's going on, okay? Now, if I didn't have any of these debug statements turned on, you can see how frustrating this could be, right? So if I have debug equals false, it's just printing out a bunch of stuff, and we have really no idea what's going on, okay? So all that's being done is, you know, printing the state, and this is all that's happening, okay? So when something like this is going on, then you have it again. It's helpful to have all of these variables that you're using to have their own little print statements. So we're going to say if debug is true, then cat I equals, and then we'll print out I. Okay. And then when we run it now we have an idea of why we're running into this issue. So I'll try F1 debug set to true, okay? And I'm going to click stop here. All right. So what we see is I is equal to 1, X gets assigned to position 1, and the state is this, and we go in and there's no winner. And all of this keeps going on and on and on. And what we notice is that within the while loop, I'm setting the value I equal to 1 inside the while loop, okay? And that's why I keeps taking on the value 1 every single time. So I'm going to just change this, and I'm going to move this assignment of I equal to 1 outside of the while loop, okay? And that way it can increment and continue updating its values. So I'll go ahead and fix my thing. We'll source it, and I'll do debug equals true. Okay, and so here it seems like, okay, finally it's doing a little bit of what I want it to do. No winner is currently true. The state is nothing. We're inside, and then we exit the function. Okay, and then I is 1, and we set X to position 1. Okay, there's still no winner. I is 2, we put X here, and there's still no winner. And then finally, there's 3 X's in a row. State is inside here, and then this seems a little bit weird. It does trigger and say X wins, but then it continues on and it puts in a fourth X here. Okay, so we have to kind of check and see, all right, why is this behaving this way? Okay, and the reason why is because after no winner is set to false, then it keeps running the code. Okay, so what we need to do is we need to set break here. Okay, all right, and let me actually we'll actually get rid of this thing here, but we'll source this, and so finally when we run this, debug is true, then it seems to behave. So after we have I equal to 3 and we assign it to here, the state's this, condition X wins for row 1 is set to true, and then prints out X wins or something like that. Okay, now this is all just to illustrate that by adding cat statements throughout your code that print out the values of the variables at their current time can be helpful in helping you figure out where you are, okay, and what's going on. And it's also helpful. So here I said we're inside function here. Probably it's also helpful to say if debug, okay, you can cat, after you call a function, you're just going to say back in primary function, back in function F1 or something like that, okay? And you can kind of help go through and navigate kind of all of these statements that are being printed out onto the screen to figure out where things are going wrong, okay? Because I'd say 99% of your problems are because you think a value has a certain variable, but when the code is running, it's actually not taking on that value. And so just awareness of where these things are is helpful. Yes, question?
Yeah, because you mentioned, it's not about this, but like last lecture you said never to use the superassign.
Yes.
So like if you wanted to like write a function that modifies a global variable, how do you do that without using superassign?
Yeah, so again, I said don't use superassignment. So notice here, what I could have done is I could have said, like, let's modify result with superassignment here, okay? But instead, what I want to do is rather than trying to run the function and have it modify result using superassignment, we keep the value result, okay? And at the very end, we return the result. And so that value that gets returned then gets assigned to result here, okay? So what you have to do is you run the function and you return that result. You don't use superassignment, if that makes sense.
What if you're like using like a for loop and you have to assign like to a position in a vector based on like the value of I?
So you need to think of a way to break down your operations into simple tasks that will output a result, and then you save that result explicitly. So you're saying you want to have a function that's going to modify, I don't know, a value in position 3 of the vector or something like that. Okay. So what you need to do is say, so what that function should do is it should take in the vector you're going to modify, within the function, it modifies the vector, and then the end of the function returns the modified vector. Okay? So rather than the function trying to modify the function directly without making a reference to it, that function should accept the vector that it's going to modify as one of its arguments. It modifies the vector within the function, and then it returns the modified vector. Okay? Because you have to keep in mind, within R, within a function, okay, it creates its own execution environment. And things don't get to, that execution environment should not be interacting with things outside of the execution environment, except through the input arguments and the return value. Okay? You can start doing it using superassignment, but then you're entering a very dangerous and confusing territory if something doesn't work exactly the way you want it to do. Okay? Yes. So
but did you superassign and it does work? Is that okay?
If you did use superassign and it does work, then good job. But you know, it's not a good practice. Okay? Because superassignment will modify values without making explicit reference to it. And I think I said in the last lecture, I gave an example where it's going to be very difficult to track down a mistake. Now, if you were able to, like for an assignment like Tic-Tac-Toe, where there's really only a few variables to keep track of, right? Like, there's really just the state variable. That's really the only thing you have to keep track of. It's not too hard, okay? But in something a little bit more complex, it can get quite challenging to track everything down if you're not aware of everything that's happening in your code. So I discourage the use of superassignment. I always go back and forth between whether I should cover it in lecture or not, because if I show it, then students are tempted to use it, even after I say don't use it. But you know, if I don't show it and if I don't say anything about it, a lot of times students discover this, like searching things on the internet, and they'll say, oh, I found this magic thing. But it's not magic, okay? It exists, but it's a dangerous thing. Stay away from it, okay? So again, yeah, a general strategy is, you know, even though we had some bugs going on here, okay, just on purpose, is that here, instead of trying to use superassign and changing the result, the value of result within the function, what I'm doing is I modify the value result inside the function, and then at the very end, I return that result. Okay, and that value that gets returned is then stored, is assigned over here to the variable result inside the f1 function. Okay, so the value result here that exists inside this function is not has no connection to the value result here in this f1 function until I use this assignment operation here. Okay, and this is also just in general, okay, and I tried to write this in my recommendations. Your functions should be simple, and your functions should not be calling other functions inside the function. Okay, each function should be take an argument in, do something to it, and return something else. Okay, within that function, you shouldn't be calling other functions, with the exception of the play function. Okay, the play function acts as a wrapper to kind of keep track of everything all together. But within that play function, you have things like update and display and check winner and all of those things. All of those things should just take in an argument and return something else. Those functions should not be calling other functions from inside, because you have to think, every time you call a function, it creates an execution environment, and these execution environments aren't able to talk to each other. Okay, so you know, so that's just something to keep in mind in order for your function writing to go smoothly. Okay. A lot of you guys have already gotten your Tic-Tac-Toe thing working, and that's great. It's meant to be, you know, a little bit challenging, but it's not meant to be overwhelming. Okay, it's about as simple of a game as we can implement as far as simple programs go in R here. Okay, all right, let's talk object-oriented programming. I got to kind of work a little bit quickly here. But in R, we have these object-oriented systems. There's 3 of them, actually, S3, S4, and reference class. And they all object-oriented systems are based around this idea of a class of an object and methods. And methods are basically functions or verbs or actions that will behave differently depending on the class of the object, okay? And then classes are often organized in some kind of hierarchy. So if a method doesn't exist for the child, then the parent's method is often used, or we'll say that the child inherits behavior from the parent. So the classes are often arranged in a hierarchy. So the most common system of object-oriented things in R is S3, okay? S3 uses what's called generic function object-oriented, and this is a little bit strange if you're coming from another language. So if you've learned other languages like C or Java or Python or whatever, they use message passing object-oriented systems, okay? But R uses what's called a generic function object-oriented system. If you've never encountered object-oriented systems, then that's great, and we're gonna learn S3, and you won't be confused as to why it's so different, okay? S4 is very similar to R's S3 system, except it's formalized, okay? S3 is very casual, it's ad hoc, you just kind of create new classes on the fly. S4 requires formal class definitions, okay? And then lastly, we have something called reference classes, and this was because people were saying, I want to have object-oriented stuff that acts like Java and C++. And so reference classes implements that style, the message passing object-oriented thing, where the methods belong to the class, okay? In generic function, the methods belong to the function, okay? And then there's also base types. We've already covered base types. Base types cover things like the atomic vector of integer and character and of type. Those types also lists and functions and things like that, okay? So, we've covered the base vector types, the lists. We've also learned about functions, and then there's also environments, and we have calls and promises, and these are all built on C, and you can ask what they are using type of. Okay? There's a few things, so for most of these base types, you can say, type of, and it'll say integer, and then you can say is.integer, and it'll say true. There's a few things that are a little bit weird. So when you say type of for a function, it says closure, but then if you want to ask, is it a function, you ask, is it function, okay? But other than that, most of these are fine, okay? There's also built-in functions, but they're also known as primitives, okay? If it's a base type, when you ask is object will return false, okay? If it's an S3 object or an S4 object or reference class, is object will return true. Other than that, is object will return false for base types. So S3 is the object-oriented system that I'm going to require you guys to learn, and you'll be tested on S3 stuff. I won't test you on S4 or a reference class, okay? There's no function for seeing if something is S3. The way we do it is we have to say, is it an object? That will return true. And then we ask, is it S4? And S4 should be false, okay? So for example, a data frame is an object. It's not a base type, right? If we ask the type of for a data frame, what will it say? A data frame is built out of what? Base type. It's built out of a list, right? Data frames are built on top of lists, and it's just that the list elements all have to be of the same length, okay? So data frame is of class data frame. It's an S3 object type, and so if we ask, so here I'm creating a data frame. X is the values 1 through 10, and Y is letters A through whatever the 10th letter is. I, J, something? Okay. And if we ask, is it an object, it's going to say true, right? And if we ask, is it S4, it's going to say false. So because it's an object that's not S4, it's going to be an S3 object type. If I do df $x, what does this do? It extracts the first column, which is, what's its type? Type integer, right? Because it reduces, it extracts the first column and gives me back basically 1 through 10 integer. And so it's type integer, and we ask, is it an object? It's going to be a false, okay? If I say df $y, what does that pull out? It pulls out the letters A through J, but the default for data frames is it creates things as factors, right? Strings become factors, and factors are an object, okay? Factors are built out of what? What's the type of a factor? Okay, it's an integer type, right? So the base type is an integer, but it obviously doesn't look like an integer, and that's because it's a factor. And the factors are, it's an object that's built on top of, one of the base types. So it's going to say it is an object. Okay? So, why do we bother with the object-oriented stuff? Okay? With object-oriented systems like this, we have functions that behave differently based on the class, okay? And technically, in the R code, there's like 100 different print functions, okay? When you say print out this vector, it prints it out. And then when you say here's a data frame and you say print the data frame, it prints it out. But underneath the hood, R is executing different code, okay? Because the data frame is actually a list. But when you print the data frame, it doesn't look like the way R prints out a list, right? And what's going on is that R says, oh, you have given me a data frame, so when I print this thing, I'm not going to print it out like a list. I'm going to look up the code for printing out a data frame, and it prints out the data frame on the screen, okay? But for us, when we write our commands, we don't have to say, oh, this is a data frame, so I need to call this special function, printing the data frame. Okay, I can just call print, and I can give our different objects, and I'll say print this vector, print this data frame, print this list, print this linear model object, print this whatever, this other thing that I've created, and it will behave differently for each of these object types. Okay, it'll look at the class of the object, and it will look up the special version of the code. Okay, there's other things like the summary function and the mean function. Okay, these are all called generic functions, and when you execute the generic function, it's going to say what kind of objects do I have, and it will look up the special version of its function and use it. Okay. As people, we do something similar, okay? So for example, if I hand you a baseball bat and I say swing, you would take the baseball bat and you would swing it, right? Like a baseball player, okay? You would put it behind your head and shoulder, and then you would swing it as if it, because it's a baseball bat, right? On the other hand, if I gave you a golf club, okay, if I give you a golf club and I say swing, your motion will not be exactly the same. With the golf club and I say swing, you would put your head down and you'd start off with the golf club at the floor, and then you'd pull it up and swing it around, right? Your motion for swinging the golf club looks different from the motion for swinging the baseball bat, okay? And if I gave you something else like a book or something and I say swing, you might be a little bit confused, but you'll figure something out, right? And you'll do an entirely different motion as well, okay? And so that's kind of how generic function object-oriented systems work, okay? You have the same verb, swing or print, and depending on the object that you have in your hands, the action or the motion, the thing that you do will be a little bit different, okay? And that's what R is doing, okay? And so we can tell if we have this generic function when you look at the definition of the function. So if you call mean but you don't use the parentheses, you'll actually get the definition of the function, and within there you'll see this thing that says use method mean. Okay, and use method does something called method dispatch. It will say, oh, the person is asking me to find the mean of some object. Okay, and so what I need to do is I need to figure out what kind of object it is that I have, and then and it will figure out, it will use that version of mean. Okay, so for example, if I give you, in the same way, if I give you the baseball bat, your brain looks at the object and says, oh, this is a baseball bat. Okay, so you figured out the class of object that you have, and then I say swing, and you say, okay, for objects of class baseball bat, the action for swing looks like this, and it's swinging like a baseball player. Okay, and if I give you like a cricket bat, if you've never seen cricket, then your brain would have to say, okay, well, my default motion should look like this, but those of you who have seen cricket players play, you might swing it a different way because you might have an idea of how this works, right? But anyway, that's what you have there. Okay. The way these generic functions and their specific methods work is they are named using the generic function name dot the class. Okay. So if you call the mean function, which is the generic function, and you give it an object of class date, what it does is it actually runs the mean.date function. Okay, so R's method dispatch will say, I'm going to look for the function mean.date because this is a date class object, and so the version of the function I need to run is mean.date. Okay, mean is generic, and it's going to run mean.date. Okay, and if you say I want to print out a factor, what R does is it says, well, print is the generic, and so it's going to run the code for print.factor. All right, and you can actually see this when if you start typing in print, okay, and if before you put on any parentheses, a lot of times this menu will pop up, and you'll get a print.by and print all of this stuff. And you can see, all right, oh, I've got print.factor, okay? And this is the specific version of the print function for objects of class factor. And if you get rid of the parentheses, you can actually see the code that is being run when you call print.factor. Okay, so when you call print.fact, when you call print on a factor object, this is the code that's actually being run, okay? Because if I say factor is going to be okay, so this is when we print out a factor, it looks like this. Okay, but if we say type of for the factor, it's actually integer type, right? And so if I say print fa, it prints the factor, and I can call print factor on the factor. But I can also do print default, okay, and they say, treat it as if it were an integer, and here it looks like an integer here, okay? So when you do the factor, okay, R is going to say, well, what is this class? It's going to say class factor, and then it figures out which version of the function to run, okay? So this can cause ambiguity if you use dots in object names, okay? So for example, there's a function called t-test, okay, t.test. And the way this is written, it looks like it's actually the transpose method, because there's a function called t that applies to matrices, right? And it looks like this is the t method for objects that are of class test, okay? But that's actually not the case. It's actually the t-test function, okay? Students t-test. And similarly, you got print.dataframe, print.data.frame, and this is actually the print method for objects of data.frame. but somebody else could be confused and say, is this the print.data function applied to types, objects of class frame, right? So we discourage the use of dots. R is aware of these things, but yeah. And there's a function library called prior, which will kind of determine these things, if it's a generic or if it's a method, and these things can be found. Yes?
It's a question of different packages.
Yeah.
For assignments, are we allowed to use like packages on the internet, or are we only allowed to use like base packages?
For example,
I don't know, just like, for example, like this game, Tic-Tac-Toe, like if we found some package that made it easier to implement, can we use the package, or can we only use the base?
I guess for this Tic-Tac-Toe assignment, I would rather you stick to the base. I think in most of these assignments, I will either tell you the package, like I will give you the packages that you can use, but in general, you should stick to the base. I think it's important to get a good foundation with some of the base methods first, and then yeah, as you find things that get easier, it's gonna go, okay. And as far as grading the Tic-Tac-Toe goes, all the graders are gonna do is they're not gonna read through your code. What they're gonna do is they're going to just load, they're gonna clear out their workspace, they're gonna source your file, and they're gonna type in play, okay. And I've got a few test cases, right? I've given them instructions, try to see if the computer will block and things like that. We'll start off with a 2-player game and try out these different scenarios. I've got a few things, do some illegal operations, see if the game stops that and things like that. And they're gonna just see if your game passes those test operations. They're not gonna actually read through the code. We don't have time to go through hundreds of lines of code for every single student, okay? So we're gonna just spend probably a couple minutes for each student running a few test cases, and you'll be evaluated on that, okay? We just want to know if it works, right? It's like if you release a game on the App Store, and if it doesn't work, then you're gonna get 1 star, okay? So, okay, so anyway, here is just a simple example. Here I created a matrix with 4 rows, and if I call function t on x, it transposes it, right? And this doesn't seem impressive, but it actually is, right? Here I've created a data frame, also with 4 rows and 3 columns, and when I transpose it, and when I call t on it, it transposes it, okay? But what's actually happening is that here, this call of t uses the default method of t for matrices, and it transposes the matrix, whereas this call of t says, oh, this is a data frame, which is actually implemented as a list. It's stored as a list in the base type, but R recognizes that it's a data frame, and it uses a different version of the code to transpose the matrix. Okay, so something different is happening here in order to make this happen. Okay. You can always look up the methods that are associated with a generic function using methods. So the generic function mean, you can call methods, and we'll see, oh, there's different versions, right? You have the default version of mean, but you also have mean for date specific objects, mean for time difference objects, and things like that. T-test, there's 2 versions of the t-test. There's the default t-test, for if you give it a vector of x and a vector of y, it's going to compare the means of those 2 things using the central limit theorem, versus t-test.formula. You can give it a data frame, and you say, is this variable associated with this variable? Okay. If you have an object of a certain class, here I've got classes TS for class timestamp class objects. We can also ask, what are all the special methods that exist for this type of object, for this class of object? And you have a difference and an aggregate and time. Print method exists for all of these things. Okay, defining a class in R with S3 is very simple. All you have to do is create an object, and then you just set the class. Or you can use this command structure and just say class is foo, okay? And that's it. So if I say foo is an empty list, and then class of this object is going to be the character string foo, then suddenly we have created a new class of class foo, okay? And we can just say, well, what is the class of foo? It's foo, and we can say, does it inherit the properties of objects of class foo? And it's going to say true, and things like that, okay? It's very very quick. There's nothing formal, okay? Objects, the class of an object can actually be a vector. So here, when you run GLM, which creates a generalized linear model for things like logistic regression and stuff like that, you can, the output of that model will be of class GLM, okay? But it's not just class GLM, it's also class LM, okay, for linear model objects. And so when you give R a command like print, it's going to first see, is there a specific method of print for GLM type objects? And if there is, it's going to use that method. But if it doesn't find print.glm, it's going to look for methods that are specific to LM, okay? So, I don't know, I guess you can have like a person can belong to a hierarchy of classes, right? So at the base level, it'll be the most specific. Maybe this will be like a British person, and then at the next level it'll be English-speaking person, and then at the third level it'll be human, right? And if we say greet this person, and you might say, oh, well, this person is British, and so you might say, I don't know, good day, or something like that, right? But if you didn't know what the appropriate greeting is for a British-speaking, not a British, like a British person, you might just say, well, an English, okay, less specific would be English-speaking person, and you might say hello, which would still be an appropriate greeting, okay? And then lastly, if you didn't know that they were English-speaking and you just said greet the person, you might just smile and wave or something, which is pretty universal for the entire world. So that's fine, okay? We're going to run out of time here for this, so we'll continue this on Monday. But we'll talk object-oriented systems then. Okay. Have a good weekend, you guys.